All right, so I think I'm recording. I want to take a look at these 6 problems on this skill 8F again on problems 4 through 9, or yeah, 4 through 9. Um, and this, last time in the video that I labeled version 1, I simply used a 30, 60, 90 degree triangle and 45, 45, 90 degree triangle because I know the lengths of the sides of those similar triangles. Well, all 30, 60, 90 are similar to each other, and all 45, 45, 90 are similar to each other, is what I mean. But if I'm trying to use the trig identities, if the nature of this is to try to relate cosine pi over 6 through to sine pi over 6 using identities, I would start out with the Pythagorean identity, and I would say that the sine squared of pi over 6 plus the cosine squared of pi over 6 is equal to 1. That's what, if you look in your skill notes for the Pythagorean identity, this pi over 6, it'll have theta in there, meaning that it's true for all angles, and so it's definitely true for pi over 6. So if I solve this equation for cosine of pi over 6, what do I have? I have cosine squared pi over 6 is equal to 1 minus the sine squared of pi over 6, and pi over 6 is in the first quadrant, so when I take the square root, I don't have to worry about plus or minus. I know it's going to be positive, and I've got 1 minus sine squared of pi over 6. And they give me in the information above what sine of pi over 6 is. So I know now that the cosine of pi over 6 is 1 minus the sine of pi over 6 is 1/2. And if I square that, what do I get? Well, I'm going to remove this. Oh, now before I remove these directions, it says that it wants exact values, which means I can't jump in right now and plug this into a calculator and get a decimal approximation. I have to simplify the radical. Exact values do not mean decimal approximations. So that's pretty important to realize, because you can't give a final answer as a decimal number is what that means. So I'm just going to move this over to the side and move this up to give me some room. So I know that the cosine of pi over 6 is 1 minus 1/4, and 1 minus 1/4 is 3/4. And I know enough about radicals to know there's a property that says that if you have a radical of a fraction, you can take the square root of the numerator and denominator separately. So the square root of 3, I can't simplify that, but I can simplify the square root of 4. It's 2. So there's my final answer, that this is the square root of 3 over 2. Let's take a look at the next one. Cosine of pi over 4. I'm not going to use the pi over 6. I'm going to use the 45 degrees. I know that 45 degrees is equivalent to pi over 4. And again, I have a previous identity that's the cofunctions of coterminal angles. I know that sine and cosine are cofunctions of each other, and that pi over 4 and 45 degrees are complementary because they add up to 90. I can replace this pi over 4 with 45, and 45 plus 45 is 90, or you can replace this 45 with pi over 4, and pi over 4 plus pi over 4 reduces to pi over 2. So I know this answer is going to be square root 2 over 2. Now, if I'm trying to use the identities that are in 8F, I can do it another way. So using the Pythagorean identity, I can say that I know that the sine squared of pi over 4 plus the cosine squared of pi over 4 is equal to 1. It wants me to solve this for cosine of pi over 4. So I'll take the square root of 1 minus the sine squared of pi over 4. And you can see that we're going to get that same thing, because the sine of pi over 4 is the same as sine of 45. So this is radical 2 over 2, but that's being squared. When you square a radical, the radical goes away. So this cosine of pi over 4, that's equal to 1 minus, the radical goes away, and I've got 2, and 2 squared is 4. 2 over 4 reduces to 1/2, and 1 minus 1/2 is 1/2. So if I take the square root of 1/2, remember that I can take the square root of the numerator and denominator separately, and I know the square root of 1 is 1, and the square root of 2 I can't simplify, so I have to rationalize that, and the cosine of pi over 4 is the square root of 2 over 2. So I did it on a previous video just using the relationship that I have memorized for a 45, 45, 90-degree triangle. I recognized as I was writing this on this second video here that sine and cosine are cofunctions and that 45 are complementary angles, so I knew I could have immediately written square root 2 over 2. And the most recent identities that I've learned with the Pythagorean identities, I can substitute it and get the same answer. So hey, there's 3 different ways to illustrate that this answer is the square root of 2 over 2. So you got multiple ways to get the correct answer is my point. So hope that helps, and I'll talk to you later.